In this video, I'll explain to you how attenuation is affected by frequency. So first of all, let's talk about transmission through the air, which is usually the radio waves that we studied earlier on. Now, we mentioned that when we are talking about radio waves, the attenuation increases with frequency. And we referred to this table showing you the different frequencies we use for wireless transmission. So we discussed about this. We said that the higher the frequency, the greater the attenuation. But in one of the mark schemes, the recent mark schemes, in the past year question, they referred to why we need modulation. And one of the reasons they said that for these low frequency waves without modulation, that means if we were to straight away convert our voice into radio waves, then of course the radio waves will follow our frequency of our voice, which would never go above 20 kilohertz. Then the frequency will be low compared to this radio wave, because the minimum here is about 30 kilohertz. And they said that one of the reasons why we don't just transmit our voice straight away into radio waves and send it out is because there's higher attenuation. So then there's a confusion. So how come here we said the higher the frequency, the higher the attenuation, but there the frequency is in the case where you're straight away converting your audio frequency into radio waves, which has a lower frequency than this, we also say there's higher attenuation. Shouldn't it be lower attenuation? Now, first of all, we need to understand they're talking about different reasons here. Now, when you use a low frequency audio wave, which if you convert into EM radiation, the frequency would be very low. Okay, the frequency will be very low. Now, when these radio waves are transmitted, it will be received by an aerial. So let's say this is your radio and this is your aerial. Now, if the signal enters here, how the aerial receives the signal is the signal that we are sending will induce an EMF in your aerial. So why would the signal or induce an EMF in your aerial? Because we already converted into radio waves, and radio waves are electromagnetic waves, and electromagnetic waves have alternating electric and magnetic field components, and the alternating magnetic field component will induce an EMF in this aerial, which is how we pick up the signal. So the voltage is then induced, and that becomes the signal that we receive. Now, we also remember that the magnitude of the induced EMF, according to Faraday's law, is proportional to the rate of change of flux cutting. So if the flux density, varies slowly with time, that means the gradient of the graph is small. So in other words, the EMF induced here will be small. But you compare it, if you are using a high frequency radio wave, that means when this signal enters your aerial, can you see that this gradient here is steeper than this gradient here? So because the gradient is steeper, it will induce a higher EMF in your aerial. So when we use radio waves, which are higher frequencies than this, then of course you're going to induce a higher EMF in your aerial, because the gradient or the rate of change of flux linkage is higher. But this is low, so this is high. Now, when we go on to the radio frequencies now, then we said the higher the frequency, the lower the signal that you receive. That means the higher the attenuation. So how come it contradicts this idea? Now, we need to understand that once you go up to the radio frequencies, the higher the frequency, the shorter the aerial has to be. Now, why must the aerial be shorter? Because we discussed earlier on in this chapter, we said that for effective reception of the signal, the aerial has to be a quarter or half of the wavelength. Alright, half of a wavelength or quarter of a wavelength. Now, higher frequencies will definitely mean that the wavelengths are shorter. So wavelength shorter means the length of the area has to be shorter. And if the length of the area is shorter, that means the area, the effective area that the aerial can receive. That means imagine that this is the area, surface area that is receiving the signal. If it's long, there's a bigger area for the aerial to receive the signal. But if it is short, there's a smaller surface area for the aerial to receive the signal. So therefore, it will not be able to receive as much signal as if the aerial was compared to if the area was longer. So therefore, when the frequency goes up, the length of the area has to be shorter, so therefore the effective area in receiving the signal is smaller, so then the less signal will be received. So when less signal is received, the induced EMF is also smaller, so it seems like there's a greater attenuation. So in all these cases, I want you to remember that the attenuation is not due to traveling in air and losing energy in air, but rather the attenuation is due to the in these frequencies is due to length of the aerial, but in those frequencies that we wanted to convert from our audio straight away into radio wave without modulation, then the problem is the gradient is too small. All right. Now, in the case of optic fibers, okay, optic fibers, let's say this is an optic fiber, we said that normally what we will do is we would either have a choice of using red light or infrared. And the what we discussed as well, we said that it is preferable to use infrared because the wavelength is longer, okay, which means the frequency is smaller. So in this case, why we use infrared? Because there's less attenuation. When the wavelength is longer, frequency is shorter, so there's less attenuation. So what is this attenuation due to? Now, it's a different reason altogether. It is due to a phenomena called Rayleigh scattering, Rayleigh scattering, and it is actually the scattering of EM radiation when it passes through molecules or atoms which are much smaller than the wavelength. So you remember the wavelength of red light or infrared, okay, is about 10 to the power negative 7, and the size of atoms is about 10 to the power negative 10 meters. So can you see that the wavelength is much bigger than the diameter or the size of the atom? So therefore, Rayleigh scattering will occur. And Rayleigh scattering actually means that when the EM radiation passes through that medium, it will be scattered more. And if you study more about this formula, you notice that this scattering actually will increase when frequency increases or when the wavelength decreases. So which one of these two will have a higher frequency? So obviously red light. So therefore red light will cause more scattering compared to infrared.